Hey guys, this is Einar. I hope you're doing great today. Welcome to your 30th tutorial in basic statistics in Excel. Today we're going to talk about probabilities, and what I've done is I've included the probability distribution table from our last tutorial, and in this case it's throwing a dice and you get different dice values here. And we've done this 1,000 times, and based on the results we got there, we got 155 throws for 1 and 170 throws for 5. We've calculated some probabilities, some empirical probabilities, and we're going to use this to calculate the probabilities of throwing different values of x. These are the formulas we're going to be using. You can see here the formula for empirical probability distributions, which is the frequencies of a certain value of x divided by the total number of observations. And we have the formula for mutually exclusive events and the formula for independent events. Okay, so let's get right to it. What's the chance of throwing something less than 3? And that does not include 3 because we do not have less than or equal to 3. Well, I'll take the chance of throwing a 1 plus the chance of throwing a 2. And we get 0.33 is the chance. So we just added up the probabilities of throwing a 1 and a 2 because you can't get both at the same time. So what are the chances of throwing either a 1 or a 2 in one throw? Well, that's it's going to be a mutually exclusive event because you can't throw a 1 and a 2 in the same throw. So therefore we just add the two probabilities together. What's the chance of throwing something above 2? Well, we take the probability of throwing a 3 plus 4 plus 5 plus 6. And we get 0.667 is the probability. What's the probability of throwing exactly 5? Well, we just choose the probability of throwing a 5. And we get that probability. So that's how you calculate the probability for mutually exclusive events. With independent events, we have to be really clear here. We're talking about throwing, we have 2 throws with the dice. And I want to get 2 6s, or a 5 and a 6, or a 5 and a 6 and a 4, or a 3 and a 2 and a 1. It doesn't matter which order they're coming in, okay? We might as well get a 6 and a 5 here. That's the same probability. That's what we're calculating here. So don't mind the order these numbers are in. That's not proper calculating, okay? And then we're going to use this formula. So you multiply the probabilities together. So we have several throws of the dice. So what's the chance of throwing the dice twice and getting 2 6s? Well, we multiply the probability here in the frequency table of throwing a 6, multiplied by the probability of getting a 6 again, and we get a pretty low probability. But there it is. What's the chance of throwing a 5 and a 6, or a 6 and a 5? In this case, well, we take the chance of throwing a 5, multiply by the chance of throwing a 6, and we get the same probability. What's the chance of throwing a 5 and a 6 and a 4? Well, let's check it out. Chance of throwing a 5 by the chance of throwing a 6 by the chance of throwing a 4. And we get an extremely low probability. Now these are the chances of throwing either a 5 and a 6 and a 4, or a 4 and a 5 and a 6, or a 6 and a 5 and a 4. You know, we can throw these around in different orders. Let's throw a 3 and a 2 and a 1. We go the chance of 3 multiplied by the chance of 1, for example. I'm just doing that to make it really clear what we're talking about. Or 2. And that's our probability. So that's how you calculate your probability for independent events. Now what does independent mean in this case? Well, it means that the chance of throwing a 6 is, for example, it's not going to be dependent on the chance you get for throwing a 5. So they are independent events. But this is a theoretical idea too, because when we're using an empirical distribution like this, they will affect each other. I mean, if we suddenly get a lot of 6s thrown, it's going to increase the shares it has in the probability distributions, which will affect the others. But it's not that we're talking about. We're talking theoretically. When I throw the dice, the chances of getting a value for each, in theory, are just going to be the same anyway. So that's what we're talking about. Have some fun with this. Try changing the probabilities. Try changing the number of frequencies in our table. And calculate the probabilities of getting different values for x. And I hope to see you in the next tutorial. So see you later. Bye bye.